So let's look at third problem on YDSE. This is a typical YDSE setup. And slits are placed 0.32 millimeter apart. So very small spacing, but still D is much larger than wavelength. That's why a large number of fringes will form. And in this case, a light of wavelength of 500 nanometer is used, and it is incident on the slit. What we need to find in this question is total number of bright fringes that are observed within the angular range of plus minus 30, inclusive of 30 degree. Okay, so we need to find total number of fringes. See here, so what is plus minus 30 degrees? So if you take plus 30 degree, so if I mark this point here, point on the screen, its position could be defined in terms of y coordinate or angular position, angular subtended at the midpoint of the slit. This angle is given at 30 degree, and we know this is central bright fringe here. As we move away from central bright fringe, here the path difference is 0. Path difference keep increasing, and every point where path difference is multiple of lambda, we keep having a bright fringe. So here also, to find number of bright fringes, we need to find what is the path difference at the point where angular position is 30. And here we can use approximation. Path difference will be equal to delta x d sine 30, and which comes equal to half of it, 0.16 millimeter. That's the path difference. Let's understand here. And path difference, number of bright fringes will form depend on this path difference is equivalent to how many wavelengths. Okay, so suppose this path difference, just to take two examples here, suppose the path difference comes to 20.5 wavelength. If we divide path difference by lambda, and if the number comes to 20.5, so if it is 20.5 at 1, 2, 3, 4, 20 bright fringes will form within this. That's what it means. So number of bright fringes is equal to path difference divided by lambda. That many times the path difference is compared to wavelength. And greatest integer function, we round it off to greatest integer. And in this particular case, it comes exactly to 320. So what is exact 320? It is exact multiple of 320. It means path difference at a point corresponding to angular position of 30 degree is this path difference is equal to 320 times lambda. So it implies at this particular point, exactly at 30 degree, 3/20th bright fringe will form. And since this is inclusive of 30 degree, even this bright fringe also, we need to include in our count. So how many bright fringes are forming in this region? About the central bright fringe, 320 bright fringes. Similar way, minus 30 also 320 bright fringes. So total number of bright fringes which will form here would be equal to into 320 center bright fringe, which will be equal to 641. That many bright fringes will form. And we can think of, would all the bright fringes be of equal width? No. The bright fringes are almost of equal width when the theta is small here. This theta is not small here. This is already 30 degree. So except for the region which is close to central bright fringes, other places the fringes fringe width will not be uniform. And we can actually figure it out as we go away from central bright fringe. The fringe width will keep increasing. Okay. So this is the question.